Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to the first lesson in our fourth chemistry unit. During this unit, we will be learning about oxidation and reduction, including redox reactions. We will cover a method for balancing these reactions. Later in this unit, we will cover electrolytic cells, learning how to label its parts. Let us get started. Today, we will start by learning about oxidation. But what is oxidation? And how do we know when it has taken place? The term oxidation originally only meant that an element had been combined with oxygen during a reaction. The combination of magnesium with oxygen is a good example, as it involves the oxidation of magnesium. These days, the term oxidation has a much broader meaning. It does not just refer to reactions involving oxygen. Oxidation now refers to the loss of electrons and is identified by an increase in oxidation number. An oxidation number is a number that shows the electric charge an atom appears to have in a compound or molecule. We will be learning more about these reactions shortly. The oxidation number can be represented by Roman numerals written to the right of an element symbol as a superscript or in parenthesis following the name. The opposite of oxidation is reduction. Reduction originally referred to the production of a metal from an ore. However, through time, the meaning of this term has also broadened. The definition of reduction now includes other reactions as well, reducing ore to metal. Reduction is the gain of electrons, and it is identified by a decrease in oxidation number. Oxidation reduction reactions, or redox reactions, refer simply to a change in oxidation number. The oxidation portion of the term refers to an increase in oxidation number, while the reduction portion of the term refers to the decrease in oxidation number. The process can be simple or complex. In the redox process, the reducing agent transfers electrons to the oxidant. Thus, the reducing agent loses electrons and is oxidized. In contrast, the oxidizing agent gains electrons and is reduced. Let us look at an example. In this reaction between hydrogen, H2, and fluorine, F2, hydrogen is being oxidized and fluorine is being reduced. The law of conservation of mass states that matter can neither be created nor destroyed in a normal reaction. Therefore, a chemical equation must have an equal number of atoms of each element on the reactant and product sides. The net electrical charge on both sides of the equation must also be equal. In a redox reaction, the total number of electrons gained by the oxidizing agent is equal to the total number of electrons lost by the reducing agent. The change in oxidation number method is based on this fact. Students, let us do an activity. We have been talking about oxidation and reduction. In a moment, several defining characteristics will appear on the screen. Please copy them all onto a piece of paper. Circle the characteristics that belong to oxidation and underline the characteristics that belong to reduction.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Were you able to identify which characteristics belong to oxidation and which belong to reduction? If you said oxidation is characterized by a loss of electrons and increase in oxidation number, then you are correct. You were also correct to say that reduction is characterized by a decrease in oxidation number, a gain of electrons, and it is a way to produce metal from ore. Let us continue. In order to balance a reaction equation using the change in oxidation number method, you must follow a number of steps. After writing the unbalanced chemical equation, assign oxidation numbers to each atom. Determine which atoms are changing their oxidation number. For each atom per molecule that is undergoing oxidation, determine the number of electrons lost. Also, determine the number of electrons gained by each atom per molecule being reduced. Balance the number of electrons lost in oxidation with those gained in reduction. Do this by adjusting the coefficients of substances being oxidized or reduced. Then, count the atoms to make sure the remaining substances are balanced. Double check the final whole equation to make sure everything is balanced. Students, let us do an exercise. In a moment, an unbalanced equation will appear on the screen. Use the steps you just learned to balance it using the change in oxidation number method.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Did your equation balance? Teacher, please go over this equation with the students at the end of the lesson. If you got the answer C plus 2H2SO4 to CO2 plus 2SO2 plus 2H2O, then you are correct. We know the equation is balanced because the number of atoms on the reactant side is equal to the number of atoms on the product side. Also, the net charge is 0 on each side. During today's lesson, we learned about oxidation and reduction. We looked at redox reactions and the oxidizing and reducing agents that play a role in balancing reaction equations. And that is all for today's lesson, everyone. Until next time, thank you, teacher. Thank you, students.